In the late 18th century, minerals fascinated chemists across Europe. Scientists were eager to understand what substances were present inside the crystals found in nature. Among the minerals, beryl captured their attention. Beryl is found in nature in different varieties with attractive colors. Their durability has made them brilliant gemstones from ancient days to recent times. Emerald was mined by Egyptians as early as 1500 BC. Cleopatra was famously associated with emeralds, which were used for both jewelry and to signify status. Emerald is the green variety of beryl. The pure form of beryl is goshenite. Goshenite can be thought of as the parent form of colored beryllium gems with no trace amounts of impurities. Pale green to dark green emerald contains traces of chromium 3 and vanadium 3. Yellow or golden heliodor contains trace amounts of iron 3, that is ferric iron. Light blue aquamarine contains traces of iron 2, that is ferrous iron. Dark blue maxi contains traces of both iron 2 and iron 3. Pink or rose morganite contains impurities of manganese 2, and red bixbyite contains traces of manganese 3. To jewelers, these minerals were valuable gemstones, but to a chemist, they were complex chemical compounds waiting to be understood. Imagine holding an emerald in your hand. Its deep green color has mesmerized people for centuries. But hidden inside this sparkling gemstone was a scientific secret, an element that puzzled chemists for decades. That hidden element is beryllium. The discovery of this element is a remarkable story of curiosity, careful observation, and persistent scientific investigation. The story begins with the chemist Frederick Oshart, who decided to study beryl from a chemical perspective. In his laboratory, Oshart carefully analyzed the mineral, hoping to determine exactly what substance it contained. Each time he performed his experiments, he obtained the same results. His analysis showed that about 21.7% of the mineral was silica or silicon dioxide. 60% was alumina, which is aluminum oxide. In addition, the mineral contained about 5% iron oxide and 8% calcium oxide. They accounted for about 95% of the mineral. But this result raised a provocative question. What about the remaining 5%? Harshad could not explain it. Something was clearly present in the mineral, yet it evaded identification. He could detect its presence indirectly, but he could not determine exactly what it was. The substance that is present in the missing fraction of beryl remained a mystery. Soon another chemist, Klaproth, entered the story. In 1797, Klaproth carried out detailed analysis of emerald. Using the best chemical methods available, he carefully studied their composition. He also examined earlier research findings by the Russian chemist Golitsyn, who had previously studied emerald. Combining Goldstein's observations with his own experiments, Klaproth reported that emerald contained about 66% silica, 31% alumina, along with a very small amount of iron oxide. Together, these components account for 98% of the mineral. What was the remaining 2%? Clapeyron could not determine its nature. The analytical techniques of the time were simply not advanced enough to identify such a small component. Still, he realized something important. The unexplained portion was not part of the usual substances known to occur in beryl. Something else must be present. This raised an exciting possibility. Perhaps an unknown substance was hidden inside the mineral. For 30 years, scientists believed that this mysterious component was simply aluminium. The reason was understandable. Beryllium and aluminum form compounds that behave very similarly in chemical reactions. Using the experimental methods available at that time, it was extremely difficult to distinguish between them. As a result, the hidden element inside beryl remained unrecognized. The mystery finally began to unravel in 1798 when the French chemist Vauquelin began studying the minerals beryl and emerald. Scientists already believed that these minerals contained aluminum oxide along with silica and other substances. But when Vauquelin examined them more closely, he noticed something unusual. The oxide present in the mineral did not behave exactly like aluminum oxide. Its chemical reactions were slightly different. Through careful and repeated experiments, Vauquelin realized that the mineral contained an entirely new oxide. This new compound was later named beryllium oxide. At first, the element associated with this oxide was named as glucinium. The name came from Greek word glykis, meaning sweet, because some of its salts had a sweet taste. Later chemists adopted the name beryllium, derived from the word beryl, the mineral from which the element had first been found. However, identifying an oxide was different from isolating the pure metal. At the end of the 18th century, chemists often struggled to obtain pure metals from their compounds. Many a number of elements were known only through their oxides. For 3 decades, the metal beryllium remained elusive. Finally, in 1828, two chemists working independently succeeded in isolating beryllium metal. The German chemist Friedrich Hohler and the French chemist Bouzy both managed to produce metallic beryllium. They achieved this by reducing beryllium chloride with potassium metal, a reaction that finally yielded small quantities of pure element beryllium. After almost 30 years of investigation, the mysterious substance hidden inside beryl had finally been revealed as a new element of the periodic table. But why had scientists confused beryllium with aluminum for so long? The answer lies in chemical similarity. Beryllium and aluminum form oxides and salts that behave in similar ways. Their compounds react with acids and bases in the same way. Without modern instruments such as spectroscopy or X-ray analysis, chemists have to rely entirely on chemical analysis and careful observation. This made the discovery of new elements slow and sometimes uncertain. But Vauquelin was able to find some differences also between beryllium and aluminum. Aluminum forms alums, whereas beryllium does not. Once scientists began studying beryllium more closely, they discovered that it possessed remarkable physical properties. Beryllium is an extremely light metal with a density of only about 1.85 grams per cubic centimeter, much lighter than other structural metals, magnesium, aluminum, and titanium. At the same time, it is exceptionally stiff and strong for its weight. This unusual combination makes beryllium highly valuable in modern engineering. It is widely used in aerospace technology, where lightweight and rigid materials are essential for satellites and spacecraft. Another remarkable property of beryllium is that it is transparent to X-rays. Because of this, thin sheets of beryllium are used as windows in X-ray tubes, allowing X-rays to pass through while maintaining the vacuum inside the instrument. Beryllium also plays a key role in nuclear technology, where it can act as neutron moderator and reflector. Beryllium copper non-sparking tools are recognized for their corrosion resistant and highly durable properties, making them ideal for use in explosive environments. Beryllium copper alloys are strong, durable, and resistant to fatigue, making them ideal for springs, electrical connectors, and precision instruments. These alloys have found vast applications in various industries due to a combination of properties including high strength, unique electrical and thermal conductivity, corrosion resistance, and non-magnetic. At last, the hidden element revealed. Thus, an element once hidden inside a gemstone has become an important material in modern technology. However, beryllium must be handled with care. Dust or fumes containing beryllium can be dangerous if inhaled, potentially causing a serious lung condition known as chronic beryllium disease (CBD), berylliosis. Industries that work with beryllium follow strict safety procedures. The story of beryllium teaches us an important lesson about science. Nature does not reveal its secrets easily. Sometimes an element may remain hidden in plain sight, disguised as something familiar. Only through patience, curiosity, and careful experimentation can scientists uncover the truth. From a gemstone admired for its charming beauty to a metal essential for spacecraft and scientific instruments, the journey of beryllium shows how scientific knowledge evolves over time. And it leaves us with an intriguing question: how many more secrets might still be present within the minerals beneath our feet? Thank you.